Now, take two. You guys recognize these little tables. And a lot of times what you're going to have to do is figure out, is it linear? Is it quadratic? Is it cubic? Is it exponential? Is it logarithmic? You've got to figure out all these things. Logarithms are coming up. That's what's coming up after exponentials. Okay? So selected values from several exponential functions. That's why I tell you to read. Read. Because a lot of times they might tell you what it is. This time they do. They tell you it's exponential. However, you should somewhat be able to look at it and notice that I'm going from 7 to 13. It could be linear. That could be quadratic. That could be a lot of things. But then I'm going all the way up to 25, and I'm going to 49, and I'm going to 97. I'm going up fairly darn quick. Now, it still could be quadratic, and it still could be cubic, just right, because they go up pretty quick too. But then that's why they tell you it's exponential. So just make sure you kind of understand all that stuff, right? Also, they notice on the left-hand side, you got the 0 and the 1 and the 2 and the 3 and the 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. That's what's very common. They like to go from 0 to whatever. Okay, so they like to go by those common inputs. But here's what they want you to do on this one. For each, find the constant value. So a constant value, you know what a constant is. A constant is just a number that can be added / subtracted to the output values to reveal a multiplication growth pattern, and then write the equation to model that function. Okay, so let me try to explain to you the way that I would go about doing this. And I remember, I'm telling you, 2 years ago, this was brutal. I think I figured out a way to not make it as brutal. So here's what we're going to do first. We're going to do the old figure out what goes between it, because that's just what we do. And so this is a 6 difference, which doesn't help me a whole lot, because now I realize it's not multiplication, right? And so this is now going to be 12. And this is going to be, what's that, 14, 24. And now we can start seeing about what my multiplication is here, because now we're at 48. Y'all with me? We try to find, they told me it was exponential, right? They told me it was exponential. And so I like to try to find a common multiple. Well, I can't find a common multiple between here, because there's nothing I can multiply by 7 to get 13. And there's nothing I can multiply by 13 to get 25. So I can't find a common multiple doing it that way. So I'm just going to look at the difference. And so I look at the difference. And then after I look at the difference, woo, looky there. I can see the common multiple now. Times 2. Is everybody okay with that part of it? Everybody okay with that part of it? That's a big deal. That's like that R value. That's that base. That's like a big number we got to have. You got to recognize that too. And it's really hard to recognize that too from here. I can't see it over there. I can't see what it is over there. I can recognize it's probably going to be a fraction over there at least, because I'm getting smaller. So now this is what I'm going to do, because I'm trying to find a constant that has shifted this thing up or down so that I can basically write the equation of this thing. And so this is the way that I'm going to do this. It's not the best in the world, but it gets you the right answer. And it saves you from having to guess and check. Some of you guys might can figure this out just by looking at it. So I'm going to write the equation of a line like a blank, like y equals. And then I'm going to choose some a value, because I don't know what that a value is. But then I'm going to go 2 to the x. And then I'm going to do it plus. And I don't care if you put K or if you want to put B or whatever you want to put, but we're adding or subtracting something, because that's what they're asking us to do. Find that constant. Find a constant that can be added or subtracted to obtain the y values. Okay? So I'm going to put a constant out here, and I'm going to put B or K, or I put K because my B's are pretty sloppy. Y'all okay with what I've done? Okay. That's going to be on every one of these. You're going to figure out what that base is. And we're going to kind of write a blank equation. Well, now what I'm going to do is kind of set up 2 equations with 2 unknowns, because I can do 2 variables. I got 4 variables, but x and y are not really variables, because those are always part of my equation. So I have an A and I have a K. I got to figure out what the heck they are. So the best thing to do is plug and chug any 2 points, 4 points, 2. And I always choose the 0 and the 1 because those are always the easiest. So here's what I'm going to do from here. Y'all, everybody okay with this? Once we figure out that 2, this is a blank equation, and that's what you just got. We kind of know that already from my G sub n. You kind of already know that from my G sub n, because my G sub n is equal to G sub k. Then we got the base, or we got r, and you got the n minus a 1, but we're not worried about the x because it's not a horizontal. All it is a vertical. They told me it was a vertical. Okay? All right, so here's what I'm going to do. I'm going to plug and chug red. Plug and chug the y value. What was it, 7? The first one? 7. A 2 to the 0. Ooh, see how nice that is? Because what do we know 2 to the 0 is? 1, so that makes that really nice. And you may not even have to put that, but I'm going to put it to make sure that you guys can see what I'm doing. And then I'm going to put plus k. All right? And then I've got to go to another value and plug and chug that one. And unfortunately, I'm out of room. And so I apologize for that. I'm going to make more. Does yours look just like this? I'm sorry. Is it laid out just like this? Okay, thank you. Got to fix it for next year. Doesn't help you guys, but purple. And I'm going to like another one. What's the next point? 15? 13. So I'm going to put 13 equals A 2 to the 1 plus K. All right, everybody good? Okay. Now, to save my eyes and your eyes, and you're squinting and making sure I can read, and on your test you'll have lots of paper. I'm going to be able to, so you can see this thing. All right, so give me that first one again. Was it 6? Can I just put an A? 7. Well, gosh darn it. Cuss. Seven. A plus K. I took the 2 to the 0 out because that's 1. Y'all okay? 2 to the 0 out because that's 1. And then my next one was what? 13? 13? Yes. And 2 to the 1 is simply 2. Okay. Soak this up because this one's easier than the other 2. Hopefully you can see how I got those 2 equations. All right. Now you can do it one of 2 ways. You can do it by addition, elimination, I don't know what they call it, or substitution. And I would just do elimination because you can multiply either the top one or the bottom one by a negative and the case will go away. We got to solve one of the equations for one of the variables and we got to find the other one. And so you can do elimination, I think is what they call it. Maybe they call it addition. I don't remember what they call that. I used to call it elimination. Or you can use substitution. Solve this for A, plug it in down here, and then solve that for K. You can do it either way. But I'm just going to multiply this one by a negative. And then that's going to get the K's to go away. And now this is 13, or it's negative 7 and 13, which gives me, maybe they call it combination. I don't care. Who cares what they call it? I just know how to do it. 6 equals A. Pretty easy. Pretty easy. This was negative A, that's positive 2. Negative A and positive 2 is positive 1. So I got 6 equals A. So watch. If 6 equals A, and that was a 7, then that has to be a 1. If that confuses you, right? Once I figure out what A is, I can find K. I can do it here or here. Doesn't matter. If I do it here, 6 times 2 is 12. Move the 12 over here, that's a 1. K equals 1. I don't care how you do it. You got to get K as 1. You got to figure out what K is, and you got to figure out what A is. What I do, K and A, whatever variables you decide to choose. And now you have the equation of that exponential function. You're going to say f of x. We're not going to say y. And we're going to say equals. And we're going to put 6, 2 to the x. And then I got a plus 1. I like to always check to make sure. So I would typically go down to like number 4 and plug in 4 for x and make sure I get their y. And if I don't, then I got it wrong. See, that's what's kind of nice, guys. I really don't have to give you the answers because you can find the answers. You know if you got it right or wrong. You shouldn't have to check a paper over here to see if you got it wrong. You should be able to know by plugging in 4 and knowing that you got it right. You can't check an answer on a test, so check it. I'm trying to start doing better about giving you guys answers. I know that that's a different deal, but everybody, any question over that? That's an easier one than the other two, but I wanted y'all to see it. Like I went as slow as I can. Now I won't go slow the next two. All right, here we go. I need this thing. Okay, make sure I answered their question. Let's make sure I answered their question. Selected values from several exponential functions are given below. For each, find the constant value that can be added to the output values to reveal a proportional growth. Then write the equation. So the constant was 1. And then the equation was the y equals, or the f of x equals f of x. You should use f of x. F of x equals, and then we found that 6, I can't remember now, right? 2 to the k plus the 1. There you go. Whoops. Letter B. Letter B. Let's figure out. This is 8. I can't, that could be times 5. It could be times 5, but it's not because that's not 50. So again, they told me it was exponential. I'm going to figure out that this is 8, and I'm going to go here and figure out that that's 24. Uh-oh, it's looking like it's 3. Let's see, that's 4 to 70, 72. Figures out that works out nice because this is going to be 104. No, that's not right. What is it? 214. 216. Goodness gracious. I'm starting to act like I got up at 2 o'clock this morning. That R value, if you want to call it that, is 3 because we're times 3. So we got that again. We have a what? Y equals A 3 to the x plus k. We're trying to figure out that constant. And then we're going to plug and chug. So I always choose the first point and the second point because that makes it easier. So here I'm going to go ahead and plug the 0 in. And I'm going to go ahead, let's change the color a little bit. Maybe that'll help a little bit. Here we go. So I'm going to use 2 equals A. That's just going to be an A plus K. That's nice. Well, what do you mean? Where'd that 3 to the x go? I plugged in 0 for x. And if I plug in 0 for x, it's 3 to the 0. And 3 to the 0 is 1. And 1 times A is A. And so then I got to use my second equation. And my second equation is now going to be 10 equals 3A plus K. How'd I get that? Well, there's my Y value, 10. And 3 to the 1, that's my X, is 3. Now we can use elimination or substitution or whichever one you want. I would eliminate. And if you eliminate, that's a bad color I chose. If I eliminate, this is now going to be, I'm going to put this one on top, kind of, it's going to be 8 equals 2a, and a will be 4. Okay? K's cancel. Yep, we have to subtract. So this will become a negative, that become a negative, and that become a negative. The k's cancel. 3a minus a is 2a. 10 minus 2 is 8. Divide by 2, and you get 4 for a. And now I got to figure out what k is, which is really easy because I'm going to plug in the 4 right here. And 4, ooh, got to move to the other side. How about negative 2? So k is negative 2. And now you have that k is that constant that they're wanting. They're wanting that constant of negative 2. And then they also want the equation. So the equation is g of x this time. Okay. You guys I got nice to you on that last test. Some of you guys put f of x. It was supposed to be r of x. So make sure this is g of x equals, and then let's see, that a value is 4. The r value is still 3 to the x. And then I got that minus the 2. And you can put parentheses right there. You can put a dot right there. Or you can put whatever you want right there. But don't make it look like 43. And for sure, don't multiply it. Yes, no, maybe? Last one. Constants here, so we're good. Oh, this one's going down. 20, 32. Down 16. You're probably seeing it already. Down 8. Down 4. So we can see that we are times 1/2. Times 1/2. It's not times 2, because it's times 1/2. It's actually divided by 2, but we don't divide by 2. No such thing as divide by 2, so we just divide it by 2 this way. Right? Now we got to find my 2 equations, and so I didn't leave enough room for that. So let's go. I think I got enough room down here. Is that what, 63? Is that 63? Yeah. 63 equals, and then it's going to be 1/2 to the 0, which is 1. Okay, it's always going to look like that if they give you the 0 value, which they typically do. They typically give you the 0 value. And then we got 31 equals 1/2 a plus the k. Subtract them. You should probably start putting the first one first and this one second, because it'll subtract easier. This is going to be 1/2 a, subtract it. So this is 1/2 a, sorry, dadgummit. 1/2 a equals, that's what, that 32? Got to multiply both sides by 2 to get rid of the 1/2. So a is 64. Once you figure out a is 64, and if that's 63, now k is -1. And so now I can write that equation. Finally, what was that one? What x was that one? H of x equals, and I got the 64. I'm not leaving room for anything. And then I got 1/2 to the x minus the 1. That's the hardest thing about this lesson. Anybody know another way I can write that equation? There's another way I can write that equation. You can't do anything to 64 and you can't do anything to negative 1. Hit me. Not square root, because it's not a power of 1/2. Close. You're kind of on the right track. You got the 1/2. Hit me. Go ahead. Don't be bashful. Ooh, no, that's making it too hard. Hit me. Nope. Oh, go ahead. 64. 2 to the negative x. Y'all okay? Y'all see what? Instead of 1/2 to the x, you can make it 2 to the negative x. Just recognize that, because sometimes these might be multiple choices. Sometimes these might be multiple choices, and you may not see that, and you're sitting there going, I know I did this right because I know I'm freaking smart. Okay? Just recognize that. There's a different way to write these. All right, beautiful. Okay, modeling exponential functions from data. And again, notice that we got like little, yours looks like this. Is this on the next page? No, it's on the same page? Okay. All right. I thought you had a little calculator picture. Is there not a calculator picture? Where? Do I have it? I don't have a calculator picture. You have a calculator picture? Not like a little picture of a calculator? Okay, whatever. You should. You should. Not this. This wasn't what I was talking about. Okay. Example 2. 4, 0 to 30. So they've restricted the domain. They're only going from 0 to 30, and that's in minutes. You got to start recognizing what this stuff's in. So T is time, I'm guessing, it's because it says in minutes. So I'm only going from 0 to 30 minutes. The number of fans inside a large sports stadium can be modeled by an exponential function, f of t equals a b to the t. So we can see that very similar. The only difference, what we just didn't see, is we don't have a k out there. We don't have that constant. Where f represents the number of fans inside the stadium t minutes after the doors open. There are 47 people in the stadium 2 minutes after the doors open. And then there are 2602 fans in the stadium 20 minutes after the doors open. This is where you guys need to recognize what variable is what. And the number of fans is 47, which is basically my y value. And the 2 minutes is my x value or my t value, because that's the time. So they flipped them on you a little bit. Normally we're given x first and then y. Well, they gave you y and then x. So just recognize that. Okay, that's important to notice, all that stuff. Use the given data to write 2 equations that can be modeled to find the equation of the constants a and b and expression f of t. And this is important because this is a free response question on your AP test. I know it. It's on the calculator portion. And this is A. And they're going to want 2 equations with 2 unknowns. They don't care what the equation is. They want 2 equations with 2 unknowns. This should be a really, really easy question. So I already know that f of t is equal to a b to the t. Well, that's not going to solve anything. It tells me to write 2 equations. So I'm going to write 2 equations. And I'm going to put 47 for y. In A and B, I have no idea what they are. I'm going to make sure there's a multiplication sign there. And then I'm going to raise that one to the 2nd power. Because at 2 minutes, there's 47 people. And then I'm going to write another equation that tells me what? At 20 minutes, there's 2602 people. 2602 equals a b to the 20. And that would give you full marks, no problems whatsoever. I don't even need this part. That's 2 equations, like they asked me, 2 equations that can be used to find the values of the constants a and b. Now, to find a and b would be brutal without a calculator. But we don't have to do that. Now, here we go. Let's see. I don't want to, they're just going ahead and tell me this. Okay. So this all goes with it. So now what they're going to want us to do is find those equations. And so let me show you how to do that with the TI first, and then with, what's that other thing? Desmos, okay? Desmos. So you got your calculator, you got that thing on, you got to do stat, edit. And I have stuff in my stat edit. You might also, I like to clear that. Here is the easiest way to clear it. Second plus sign. Clear all lists. 3. Enter. It didn't go. Done. That clears 1, 2, 3, 4, 5, and 6. And remember, if you don't see 1, 2, 3, 4, 5, 6, set up editor. So you go to stat, set up editor if you don't see 1, 2, 3, 4, 5, 6. You really don't care if you don't see 3, 4, 5, or 6. You've just got to see 1 and 2. Edit. Why did it not clear that? Oh, because I'm an idiot? By gosh, I'll fix it this time. I clicked 3 instead of 4. 4! Now it's gone. What was the first time? 2 minutes? And the other time was 20 minutes. Careful. Don't mess this up. This is really easy if you plug it in your calculator correctly. You plug it in incorrectly, and you're not going to get the right answer. At 2 minutes, it was how many people? 47? 2602? Questions. You'll do this throughout the year several times. I think we already did it once, but I'm kind of emphasizing it again because we found, I think, a quadratic regression maybe, or cubic regression. I don't remember what we found in chapter 1, unit 1. Okay, so once the data's in there, you're good. Whatever you want to do, clear it, delete, use your calculator all day. It doesn't matter. It's not going to mess anything up. But now you got to find the equation. Stat, calculate. And it's not a one variable stats, it's not a two variable stats, it's not a median, it's not a linear regression, it's not a quadratic regression, it's not a cubic regression, it's not a quartic regression, it's not a linear regression, it's not a natural log regression. Oh, exponential regression. How do I know that? Because they freaking told me it was an exponential regression. Guess what? On the test, they're going to tell you what type of regression it is. Because with 2 points, guys, that could be anything. That could be linear, quadratic, cubic. It could be anything between 2 points. I can get from this point to this point doing all kinds of things. Hit enter. X list is L1, Y list is L2. Frequency is never anything. I always like to store it just out of habit, but you don't have to this time. But to store it, you just hit alpha trace, and that gives me Y1. So I typically store it in Y1. Again, you don't have to this time, I don't think. And then we just hit calculate. And looky there, I get Y equals A times B to the X. And they're telling me that A is 30.089011153. You're going to write down as many decimals as you want, but you better write down at least 3. And then you got 1.2498, and I don't care, you better write down at least 3. And if you're going to change that, I start getting worried now, because really that 8 bumps that up 9 to a 0, because it really bumps that up. But I hate putting 1.25 as an answer, because I'm in a bad habit of I better have 3 decimals. So I'm going to back up and I'm going to put 1.2498. And now I know I'm safe. I don't have to worry about rounding or anything. That's why you're better off just putting a 4 and not worry anything about it. Questions? Y'all okay? Easy find, yes? Desmos, really quickly. Desmos. So you're in Desmos here. You got to hit the plus sign. The plus sign brings up all these other different kinds of things. And you got expression, note, table. So here's an X and a Y. And so I'm going to plug in. Oh, I got to go down over here. I meant to bring my little 10 key today. I didn't do it. 0. Oh, it wasn't 0, it was a 2. Cuss. It's all right. Backspace. I can still just put a 2. 0, 2 is the same thing as 2. 20. Right. Up. How many cats? 40? 47. 26, oh. Beautiful. Okay. Once I have those bad boys, I don't remember what I hit. There. I hit. Oh, I'm sorry. You didn't see it. Oh! There is? Well, I didn't want that to show up. I hit it. I hit back again. Oh. Go for it. Yeah, I didn't want this little thing right here. That little check mark, that's what I hit. There may be other ways to do that. I don't know. I'm just finding this out too. Click. And it says linear regression. I don't want linear regression. I want to drop this bad boy down until I see exponential regression. And here's y equals, and it gives me the whole equation right here. Don't write y and don't write x. Make sure you write f of t and t. Yay? Questions? Okay. Let's keep going on the homework or the notes just to make sure. Where am I at? I need to go. You go away. Bye. Here. Okay, so this is telling you how to go through that. Okay, there's your L1, there's your L2, there's exponential regression, there's Stort and Y1. It gives you R squared and R. You don't need that. Selected values of an exponential function are shown in the table above, where g of x equals a times b to the x. Use the given data to write 2 equations that can be modeled to find that. They're giving you a hint again. They're prepping you guys. They're prepping you. They don't care what the equation is. Everybody can do the equation. I want to make sure you can write the equations that you need to do to find it. So that's where you got to start plugging and chugging. This isn't too bad. Let's see. Make sure I use g of x. A. Oh, I didn't really want to do g of x, did I? I want to use 8 equals a times b to the third. No, I'm dyslexic that, didn't I? See? Minus 4. 2154 is the y value. I really did that on purpose, hoping somebody caught that. And then my second equation is 3.62 a times b to the 8. Make sure you can see the multiplication sign. Make sure you can see the exponents. Make sure you can see it. We can read it. And then now it says find the values of a and b. And I'll be darned if I'm finding that without a calculator. They're not going to make you find it without a calculator. And so you either use your Desmos or you use your TI to find your A and your B. Yes, no, okay. I'm assuming we can do that. I don't want to go through that whole process again. I'll do it for this one. Okay. Stepping up to an AP question. Natural base E. E is 2.718, yada, 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 never ends, never terminates. The natural number E is used as the base of exponential functions that model contextual scenarios. Whatever. The number of bacteria B in a particular culture can be modeled by this exponential function. B of T is equal to 17 E to the 0.31 T, where T is measured in hours. Let A sub T equal B times B to the T be equivalent expression. Find the value of B. Careful. B is not 2.718. Because they tell me that this is 17 E to the 0.31 T. And you guys learned in 2.4 that if I have e to the 0.31t, that's also equal to e to the 0.31, because that's a power to a power. And if it's a power to a power, you can multiply. And now I can do e to the 0.31 because, guys, this says b to the t. It only has b to the t. And so I need b. And so I got to do e to the 0.31. And let's make sure you can do that on your calculator correctly. Don't, how do I say this? Don't round until the final answer. Because if you round before a final answer, it's possible you're going to get a rounding issue. So e is natural log. Second, natural log. There's your e to the. If you don't like that e to the, there's another one on here. Is it divide by? Yeah, that's an e. There's another e on here also, but that's an uppercase e. So 0.31, hit enter, and that's your value of b. Make sure what? 3 decimals. I like 4. 4 is safe. 3 is pushing it. So just put 4. You can put 5 or 6. Doesn't matter. The graders, here's what the graders are going to do. When they see something with a whole bunch of decimals, they take their paper and cover up after 3 because they don't care. And if there's not 3, you're taking off. So they don't care if it says 363 or, well, this one they would care because it can't say 364. Okay, beautiful. I'll go with that number. All right, let's see what's next. What's next? Find the average rate of change from 1 to 7. I thought I was done with the average rate of change. Dadgummit. We got to do y minus y over x minus x. Got to do y minus y over x minus x. And x minus x is really easy because it's just 7 minus 1. And then you got to plug in 7 and you got to plug in 1. Here's the easiest way to do that. Okay, here's the easiest. Was it 17e to the 0.31t? Here's the easiest way. Y equals, clear that nasty thing out. I've ever forgot the number. 17? 17e to the 0.31? 17e to the 0.31x. That's the equation. Here is the easiest way to plug in 1 and 7. Do alpha trace. Y'all kind of see that? That's f of 1. And then alpha trace. And that's f of 7. Don't round until the very, very end. I used to do this store, but I forgot you guys now. We have these new calculators that you can just do that minus that. And I have to divide that by 7 minus 1, 6. And there's the average rate of change, making sure you have 3 decimals. Okay? Don't round until the very, very end. Don't round the 125 and the 148 because that might give you a different number here. I'm sorry, the 148 and the 23. Because if you round that, that might give you a different 125. And if you get 125 and you divide that by 6, that might give you a bad answer. So don't round until the very, very end. That's on the rubric. So if you end up with 20.96, you're wrong. You're wrong. So don't round until the very, very end. Beautiful. Beautiful. Where am I at? I'm here. What's next? Find the number of bacteria predicted after 15 hours. That's pretty easy. Plug and chug 15. You already got it in there. Alpha trace 15. Yep.
We have a D as well.
I figured you did. Now it's going to be what? How long does it take to get?
19 bacteria.
Okay, this I need to show. That's what you got. That's how we do this. It's teamwork. It makes the dream work. Find what? The time when bacteria is 1,000? All right. 2 ways to do this, guys. 2 ways. Yep. Go ahead. It says find the value of A. Oh, that's 17. Your test is going to say find the value of B. So I'm glad you guys fixed that. Boy, I got to fix that whole thing. 2.5, fix. Beautiful. Yeah, it's not going to say find A. Find A right here. 17, got it. That's great. You guys are awesome. Y'all good with all that? If they did ask for it, it's 17. Okay? All right, so there's 2 ways to do this problem right here. 2 ways. I think one is easier than the other. But then again, that's just the way I work. So I need 1,000, right, equals, and then I got, where is it at? 17 e to the 0.31 t. Okay? So there's 2 ways to do this. Leave that 17e 0.31 t in y1 and put y2 as 1,000 and see where they touch. I think that's harder than what I'm getting ready to do because I'm going to move that 1,000 to this side. And then I'm just going to see where it crosses the x-axis. There's 2 ways to do that. Leave the 1,000, put 1,000 in y2. But now, guys, you got to move. You're going to have to do some major window moving. You got to do, because you got to see that intersection. Well, if that's 1,000, that better be at least 1,000. You follow that? Good. But I think, again, the best thing to do is just to move that 1,000. Whoops. Got too froggy. Is move that 1,000 there. Okay? And then when I graph it, I might see it and I may not. I don't. Got to do some zooming. Windows 6, zoom 6. That does what it should do. Still not enough. So I got to do some more zooming. I'm going to have to move my windows. Let's see, let's move windows. Let's make my X. I don't care about my X min. In fact, I can move that to 0. It told me it's only from 30 minutes, though, didn't it? It only told me it's from 0 to 30. Oh, there it is. I got to see where it crosses. So, second, don't trace. Don't trace. Calculate. Let it do everything for you. I need the 0. 2. Left bound. I don't care. 1. Right bound. I don't care. 29. Guess. I don't ever guess. There it is. 13.143684. Yep.
That was way faster, but I didn't want to. Can we do it divide by 17 log base?
You bet. It was way faster this way, though. Yep, they're going to want you to use your calculator on it. You won't have time to do all that, but you can do it that way. You can do it manually. Let me do that again on my calculator just to make sure you guys follow, okay? Y equals, I moved 1,000 to the other side. It told me at the very beginning that the minimum was 0 and the maximum was 30, so my guess is it had a fit there. So I went ahead and changed my window to 0 to 30. I don't care about the Y values as long as I have the Y axis on there. If I cared about the Y values, I'm going to need to put the 1,000 up there. Okay, so then I graphed it. All I care is I see that point. If I see it, my calculator can find it. Okay, so then don't trace. It's a whole lot easier if you don't trace anyway. Calculate, you want to calculate the zero. If you did the other one, you want to calculate the intersection. Okay, I don't have an intersection because I only have one graph. Calculate the zero. It asks for the left bound. I know the left bound will be 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7, whatever, as long as I'm to the left. Punch it in. Right bound, punch it in. It's a whole lot easier. 28. I know I'm safe. Guess. You can see now, I can see the left and right bounds. And it tells me to guess, and I don't ever hit guess. I just hit enter, and it tells me right then what it is. Okay? Was that the last question? Oh, there's another example? Well, I probably don't need to do that. You have a D on that one too? Yeah. Find the values of A. Oh, this one finds the values of A and B. And use these values to write the expression for D sub T. So that one you're going to have to find the equation. They didn't give you the equation in this one. That's a test question. They're not going to give you the equation. You got to find it. So L1, boom, 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 boom. Find the equation. Put that right here. There's not a lot of work to be shown. You got to find the equation. Actually, rephrase that. A part's going to say write the equation that models what it's going to take to find A and B, or whatever we did on those others. Right? Write two equations to find the two unknowns. And then it's going to say find A and B. According to the model, what is the population of deer after 6? Plug and chug 6. Find an equivalent expression where D is measured. So that's the big one. That's where you're going to rewrite it. That's where you're going to rewrite it. Find an equivalent expression. And then you have to find the intersection. Yippee, yippee, yo. A lot of calculator exercises. A lot of calculator exercises. Okay. Friday's a B. So I won't see you again until Monday. Holy cow, long time. Is what that is. You have 2 assignments. Hit me. Go ahead.
I was wondering if you could see this.
Find an equivalent expression. What's the equation? Where T is measured in months instead of years. So instead of what T you have, you're going to have 12T. Let me rephrase that. You should have T divided by 12. Because if it's 1, then you don't want, it's not 12. It's not 12 months. It is 12 months. 1 year is 12 months. Y'all with me? I'm sorry. So they want an expression where T is measured in months instead of years. And so right now, T is measured in years. So T is in years, and they want it in months, then my guess is that would just be 12T. Because if T is 2, that's 24 months. If T is 3, that's 36. So that one you just almost kind of have to think about. That's typically what they're going to do on that too. You have to divide it or multiply it by something. Great question. I'm glad you caught that. Where was I at on this? What was I talking about? Oh, 2 assignments. You have 2 assignments. I'm going to give you a worksheet and you have Delta Math. 2 assignments. Okay, Delta Math link is on Classroom. You may have to go through, what's that called? Clever, maybe. I don't know if that works or not.